In this video sizobe sidiscussa lo question 5 uphuma kule question paper ka November 2018. In the description box, check it out. Uzothola ama links for other questions engiwaphendulile for this very same question paper. Now question 5 interesting because ucover several topics. Sikhuluma ngama types of reactions, balancing ama chemical equations, as well as the law of constant composition. Well, question 5 lona ufundeka ngale ndlela ke. But study the physical and chemical processes below and answer the questions that follow. So basiphe 3 ama processes la. The first process ubani process X, process Y, process Z. So it's X, Y and Z. So lama processes ayi 3 la, right? Or lama case studies ayi 3. Kwamele siwasebenzise in order to answer the following questions. So for the first one, what you define the term physical change. Physical change. Physical change is a change in which no new substances are formed. For instance, as one. For instance, uthatha amanzi uyawaboila, right? Amanzi nawaboila ayini azomove from liquid state to what? To gaseous state. That's a physical change. That's not a chemical change, but a physical change. Because of iluganji, the chemical integrity is still intact. No new substances were formed. It just changed from one state of matter to another state of matter. So a physical change, the simple definition is a change in which no new substances are formed. I can make examples where there's a physical change. Another one, let's use amanzi again. Uthatha amanzi wafaka eluganji let's say mhlambe glazini le plastic, right? Bese uthatha ufake efridgini. After some time, after several hours, now uvula ifridge uthola sekuyini, sekuyi ice. That's what we call a physical change. So that's the definition for a physical change. 5.2. Write down the letter of the processes that represents the following physical change. 5.2.1. So out of the 3 processes, right, which one is a physical change, or which process undergoes a physical change? It's definitely X. The lama bega on the left hand side of the equation I have amanzi, and then on the right hand side I also have amanzi, but there's a change of state of a metal from solid to gas. So therefore we have a physical change to process X. So our answer is X la 5.2.2. Decomposition reaction. So with decomposition reaction, it's a reaction where you only have one substance. Mhlambe, you might apply heat energy to that substance, or you might apply in mhlambe exposure to light, and then yenzani, it starts reacting to form new substances. So which reaction out of the 3, X, Y, Z, is a decomposition reaction? It's definitely reaction bani Y, because of sine calcium carbonate as a solid, and then she apply some heat to this solid, and then yenzanya decomposer to a calcium oxide plus carbon dioxide. So lana sibane chemical change because of it's a decomposition reaction. The substances you form 2 different substances. So this is a decomposition reaction. Another example engayipha mhlambe, it's a combustion reaction of a coal, right? Angisho nangabe sithatha amalahle siyawabasa, kuba ne chemical change eyenzekayo, kuba ne decomposition reaction in that case. I hope I'm right. Ilahle na ulithatha ulishisa liyofoma amanye ama substances, right? Yes, so that's another one, chemical change. I think I believe with the decomposition reaction, but anyway. 5.3, give the name of the physical change stated in 5.2.1. bheka ke la u-5.3 bakhuluma ngobani? Sikhuluma ngo-x. 5.3, give the name of the physical change stated in question 5.2.1. Ku-5.2.1 si-identify the physical change as ubani? Process x. Let's go back to process x. Process x inani? Sinamanzi on the left hand side, sibuye sibe namanzi on the right hand side. But la manzi aku-solid state initially, and then after some time I change to a gas. But it's in name that physical change esistatile la ku 5.2.1. Angisho amanzi nangabe uyawaboila ayenzani? Aya evaporate to a gas, right? And then lawo manzi lawa in gaseous state ayi water vapor. Angisho nangabe ngi-reduce i-temperature in that space where kune water vapor khona, what happens? Lamanzi, they start doing what? They start undergoing condensation, right? Lawo ma processes lawo for the different states of matter from solid to liquid, from solid to liquid yin leyo. What's that process called? Melting. Angisho. Now we have a process la where a state of matter changes from solid to what? To gas. What is that state? What is that process called, right? What is that physical change called? It's what we call a sublimation. Uma move from a solid state to a gas, it's what we call a sublimation. This thing learners we observe, especially during summertime. So nangabe uthenga ama-ice, yabona lama ice lawo bawafake emaplastikini lawo. Okay, angazi ukuthi niwabizane nina, but kunalama ice lawo esiwathengayo man la estradeni kanje. Ama-ice wakhona aseplastikini, so leyo ice nayiphuma iloka efridgini iyi-ice, but nangabe uyayikhipha uphumele nayo ngaphandle, so uzoyibona iphuma something like i-water vapor nyana, so irradiator some vapor nyana. So sithi leyo ice undergoa ini iloka sublimation ke. That's a sublimation process. 5.4, state two properties of a reaction that indicate that a chemical change has taken place. Chemical change has taken place. We need two properties of a reaction that indicate that a chemical change has taken place. The chemical change uyibona njani ke? Yini chemical change? A chemical change is a process where the structural integrity or the chemical composition of ama reactants wethu angeke ifane the chemical composition of ama products wethu, meaning if ever ama reactants wethu aya reactor, they form new substances. That's a chemical change, right? So out of the three processes, labafuna ama properties out two. There's many, there's several properties, but lana bafuna only two. Whenever ubona a color change during a chemical reaction, it means leyo reaction lay take a place, there's going to be a chemical change, meaning the chemical composition of leyo substance leyo change, right? Change. Sometimes uthola ukuthi two substances are reactor, naka reactor sometimes anokufoma a precipitate. That's an example of a chemical change. Sometimes kunokufomeka iluganje i-gas, right? Nakufomeka i-gas, just know that a chemical change has occurred. Jengala, as I've mentioned, ku process Y, this decomposition reaction ifoma ini a solid calcium oxide and a carbon dioxide, lena i-gas ke. This gas simply suggests okay, there's a chemical change. Initially I had something else, and then after the reaction form new products or new substances. It indicates that there's a chemical change, even if no more precipitate during that chemical reaction. Just know that it's a chemical change. There's a chemical change taking place. What's next? 5.5. 5.5 for process Z. So 5.5 will focus only on process Z. Write down, okay, 5.5.1, what the symbol delta represents. Le symbol le. Nay lapha. Nay symbol yakhona. It means what? We are applying heat. That symbol simply means it's heat. Heat is being applied in a chemical reaction. 5.5.2. 5.5.2 for the process Z, write down a balanced chemical equation. Show the phases of all the reactants and products. Now process Z. Process Z, it's an ion, reactant oxygen. Kufomeka ini ion 3 oxide. Ion 3 oxide. So lo 3 nalona usitshela ukuthi this ion has a valence of what? Of 3. Yes? Has a valence of what? 3. So the ion is willing to lose 3 electrons. Since this is a metal and a non-metal coming together, kuzofomeka ini ion. So lana yini ionic bond. So the metal will lose ama electrons, and then the non-metal will gain lama electrons. The ion 3 is telling a valence, how many electrons the ion is willing to lose. Now we need to write down a balanced equation for this process Z. All right. I know that. Okay, bheka. Process Z abasiphanga basipha amagama of ama reactants as well as ama products. So thina nasiyobalansa le equation, we need to interpret process Z into into ama chemical symbols, then we balance. So ion is represented by Fe plus, and then the Fe, the ion is a solid. The ion is always found in solid state. And you call as a liquid, and you call it as a gas as well. You call as a gas. But you call as a liquid state in some exceptional, well, in some instances, mhlambe nangabe bayimelt or something, then ion ungayithola as a liquid state. But for now, the ion it's a solid. And then oxygen is gas, so we exist as a O2. So ibala as O2, right? So the O2 simply says oxygen yethu i gas. So oxygen in its natural state i gas. Angisho uyabona bathini, show the phases of all the reactants and products. So there's a mark for this solid, there's a mark for this gas as well. So be careful. Ungakhohlwa in case uhlangana ne question efana na this one, make sure ukuthi uspecify lama phases. Lama phases abakhuluma ngawo labo solid, gas, and then siya ngapha ku product ke. Okay. Ion is willing to lose how many electrons? 3. So it's 3 plus, right? And then the oxygen is willing to gain how many electrons? 2 electrons. So this oxygen na this ion 3 nazohlangana kuzoba Fe2, right? And then lo oxygen uzoba O3, right? Why is it F2O3? It's because of the lama electrons are lost. Mass wonke lama electrons azoluzwa yilo kanje ion komela gainwe oxygen. So in order ukuthi lama electrons lost and the electrons gained are balance, I need 3 yama oxygen as well as 2 yama ion. So basically into engenzile kuvele ngathatha lo 2 ngambhala la ku ion, ngathatha lo 3 ngambhala kuphi la ku oxygen. If it was 2 2, then bengiyovele ngithi FeO. Yeah, if it was Fe2 plus oxygen 2 minus, bengiyovele ngibhale FeO. Qedile-ke kanjalo, yabo. But because of the lost electrons are not the same as gained in oxygen, so in order to balance out lawo electrons, I need to say Fe2 and then O3. Now this one ke kuyoba yilo kanje, kuzoba yi-solid nayo. Even this one kuzoba yi-solid. Kuzoba yi-solid. The phase for this product it's a solid. Why ngisho njalo ke? I-iron oxide yiloka yi-rust kahle kahle. Ukurusa lo. Yabona i-iron nayi-reactor nelo kanje ne-oxygen ifoma i-rust, and i-rust is always existing as a solid. Now sesicapture ama-phases, sa-capture ama-chemical symbols for u-process bani Z. Now it's time to balance the chemical equation yethu ke manje. Alright, bheka ke la nginabu how many ions do I have? 1 on the left and then 2 on the right, and then 2 on the right. So ama ions awekho balanced, as well as ama oxygens awekho balanced. Ngapha I have 2 and then ngale I have how many? 3. So I think kubukeka natural to say komele sifake ulo kanje u2 la to balance out the ion, right? To balance out the ion. Okay, but the best idea la is to start off ngamalo kanje ngama oxygen, is to start off balancing ama oxygen siqala. Why ngisho njalo? Ngoba check out the oxygen on the left hand side, so you have sina 2 yawo. On the right hand side sina 3. So uma ngabe kuso I have even ngina even oxygens. I have an even number of oxygens on the left and an odd number of oxygen on the right. So in order to balance out la uzodinga ukuthi sithi 3 la. The why times are 3, it's because of this 3. It's sort of like a cross multiplication in a way. So by taking the odd number and multiplying out the even number la ngithola ngayike 6 yama oxygen. Alright, so now seka balance enhleka ka balancanga ama oxygens just yet. On the right hand side ngizo multiply by 2. This 2 ngimbeka la uvela from this 2. So nangabe I have even and odd numbers, try doing this first so that uzowenza life ibe lula kanjalo. Bheka ke manje, 3 times 2 is 6 oxygen. 2 times 3 is how many oxygen? 6 oxygen. Seka balancile ke manje. Yabona? Seka balancile manje. If it was even number of oxygen, bekuzoba simple that way. But if ever it's odd and if it's even and odd, try doing this iqala, then uzolandela ngalamanye amalokaji, ngalamanye ama substances ke. Now it's 2 times 2 ngina 4 yani yama ions, and then ngapha ngina 1 by placing u4 lana sengina 4 yama ions abalancile ke. 4 ions 4 ions, 2 times 2 is 4, 3 times 2 is 6 oxygen, 2 times 3 is 6 oxygen. So kubalancile ke manje. 5.6 ke manje. So calculate u 5.6 la ku 5.6 you got a 20-gram sample of calcium carbonate in process Y decomposes to form 11.2 gram of calcium oxide. In a second sample, 30 gram composes to form X gram of carbon dioxide. Now, 5.6.1, let's state the law of constant composition. Okay, let me erase lana kala and answer 5.6. Okay, now 5.6. Lagu 5.6.1, but is stated the law of constant composition. This law is stated as the law of constant composition states that no matter how a chemical compound is prepared, it always contains the same elements in the same proportion by mass. Or singati, it always contains the same elements in the same ratio by mass. Ungayistate kanjalo as well. Contains the same elements in the same proportion or ratio by mass. So basically, the law of constant composition, it involves ama ratios, right? So uzobona la ku 5.6.2 5.6.2 use the law in question 5.6.1 to calculate mass X of the carbon dioxide formed, right? Of the carbon dioxide formed. Bheka ke manje, we have two yamalokanje, two yama samples la, right? Two yama samples, and both samples both samples are undergoing the same chemical change, right? Which is a decomposition reaction. So sample number one, check out sample number one. I said the first sample, we need the ratios between the products and the reactants. A 20-gram sample of calcium carbonate in process Y decomposes to form 11.2 gram of calcium oxide. But 20 gram of calcium carbonate decomposes to form 11.2 gram of calcium oxide. This is the first sample. Now for the second sample, but in the second sample, 30 gram of calcium carbonate decomposes to form X gram of calcium, not the calcium, but carbon dioxide. So lana sifuna calculate the X, the mass X of calcium. Why so long it calcium? It's carbon dioxide. Sifuna mass X of carbon dioxide. But I cannot say, with a second sample, I cannot say it's X gram of carbon dioxide. Why ngisho njalo? Because of on the first sample ngicompare calcium carbonate and calcium oxide. On the second sample ngizothi 30 gram of calcium carbonate forms or decomposes to form X gram of calcium oxide again, right? Ama ratios asebenza kanjalo, or this law isebenza kanjalo. On the first sample is compare this and this. On the second sample I need to compare this and this again. It's calcium oxide. The calcium oxide mass is unknown as well. So now so represent ngobani ngo X gram, right? Ngo X gram. Bheka ke manje, uyabona for the first sample, the calcium carbonate na decompose izofoma 11.2 gram of calcium oxide. In other words, chaza ukuthi since naye this decompose ayifoma 1 2 yama product, mass ye calcium oxide formed and mass ye carbon dioxide formed. Now wahlanganisa, they must give you 20 gram for the first sample. For the second sample, it's also true, right? It's also true. Nangabe uzothatha 30 gram of calcium carbonate uyidecompose. Uma uzoyidecompose, the mass ye calcium oxide ne carbon dioxide now wahlanganisa, they must also give you 30 gram, right? Tina la ku 5.6.2 sifuna the mass of calcium, carbon dioxide. Bheka ke manje la, since lawa ama ratios, angisho ama ratios, so ngidinga usample 1 as well as usample 2. Ngiyothi x times 20 gram, 20 times x is equal to 30 times 11.2, right? Divided by 20 divided by 20, so 20 divided by 20, x is equal to is what? Come on, calculator. Okay. So it's what? It's 30 times 11.2 divided by 20 is equal to 16.8. 16.8 gram. The x conjugates what? It's x gram for a calcium oxide. So x is equal to 16.8 gram of a calcium oxide, right? Of a calcium oxide. Ngithe since lo x simthola kuphi ku second what sample, right? U second sample, bheka ke manje u x gram of calcium oxide nangimhlanganisa nobani no x gram of carbon dioxide, komele ngithole ngaki 30 grams. 30 grams, right? According to the law of constant composition. Nangabe ngina 20 ngapha ka left, basically into engizama ukuyisho ukuthi nangabe uno 20 ngapha ka left, ichaza ukuthi naka right komele ube nangaki, ube na 20. Nangabe una 30 on your left, on your right you must also you need to also have ngaki 30 nakhona, right? So that's why ngithi x gram of calcium oxide plus x gram of carbon dioxide is equal to 30. It's the same as the left hand side. Now bheka ke manje, since nginayo the number of grams for calcium oxide 16.8, sicalculatile, plus x gram of calcium dioxide is equal to 30. Now this is going to be equal to x gram of carbon dioxide is equal to 30 subtract 16.8, which is equal to bani. Let us see is what is 30 minus 16.8. Answer is 13.2. About 13.2 grams. So this is the answer for x gram, or the mass x of carbon dioxide. So calculate ngalendlela. So the law of constant composition will involve ama ratio. Ama ratio wakhona, they come as ama samples out 2, right? It's sort of like a simultaneous equation. Remember ku mathematics, you need 2 yama equations to solve for x and y, but lana solve for x and y, but in order to establish a ratio, you need 2 yama equations or 2 ratios, so that you cross multiply ukwazi ukwenza the unknown the subject of the formula. So I hope I didn't confusanga kakhulu. So lana Lana, the 5.6.2 is the last question for question 5. Thanks for tuning in. Nangabe unama questions or there's anything understandanga kahle la, let us talk in the comment section. Don't forget to like, share and subscribe nangabe new to this channel. So yeah, in the description box check amanye ama-video engiwarecordile for this question paper. For now, asibonane on the next video.